Hello everyone, this is my second code along project on reinforcement learning. But in this video, we are going to do DQNs. Our first video was on deep learning, on Q learning rather. So right now we are switching over to DQNs. But what are DQNs? Now, Deep Q network or DQN is a deep reinforcement learning algorithm that combines Q learning with deep neural networks. Basically, that's what it is. It was introduced by DeepMind in 2015, and since then it kind of revolutionized the entire reinforcement learning concept altogether. Now it's used in robotics, it's used in military applications, and many other applications that you might think of. So basically, I don't want to go into detail how deep learning works. I assume that you've already done your theory part of it. Now you're here to kind of have a hands-on project, understanding on how it works. All right, so the goal of our project today is to train an AI agent to become a paw on a moving cat using DeepQN. So our key objectives are to train a reinforcement learning agent using DeepQN to play the cat paw version 1 environment, to optimize the agent reward by maximizing the time the paw stays upright, to implement dueling DQNs and double DQN for better stability and performance, and also to achieve reward score of 175 plus solved within 500 episodes. Now we are going to use the CatPaw version 1 environment, which is a classic control problem from OpenIGym, where an agent controls the cat moving along a track with a paw balanced on top. I'll append a video so that you can see what I mean. But basically, what we are doing here is to we are balancing a paw on a moving cat. So we have two options. We can either move right or left. So depending on where the paw is leaning, we want the agent to move either right or left so that it maintains the balance. All right, so I'm going to jump over to my Jupyter notebook and start to code along. And let's get started and see what our agent will do. So remember, our goal is to solve the environment. The agent must achieve an average score of 475 plus over 100 consecutive episodes. I'm going to do a maximum of 500 episodes, but you can come up with whatever you want and make sure your agent works as you expect. All right, so let's get started. I am going to now, if you have not installed these libraries, so you're gonna pip install Gym, NumPy, all those. I'm gonna use NumPy. One random. We also want touch. Actually, let me do it this way. Then, yeah, this is what you want. I've already installed them, so I don't need to install this. So I'm just going to import. All right, import. I'll start with Gym, where we're gonna get the environment. I want to import NumPy as np. I'm going to import random, import touch. Let's go ahead. SNN, import. Then from collections, import DQ. Perfect. All right. What I want to do here is to maybe increase the size a little bit. Perfecto. And I'm going to write the giant code for you, but you can do cell by cell if you want. So what we need to do here is to define. I want to define the Dueling DQN network. So to do that, I'll do class dot module. Let's initialize it. I want my state size here and action size. Perfect. self. Perfecto. Dot linear, then state size 128. Perfect. Then self, again, linear, size 128. Basically, I'm defining. Let me define the value stream here. One to eight action size. Right, perfect. Actually, yeah. Then the advantage stream, oneself dot value action size. Then under this class, we need to go ahead and do a function. All right. Self.fc1 then let's go ahead and do, I'll copy this and do another x dot, this will be 2. Yep. Then let's do under the function value is equals to self.value of x, then also advantage is equals to self.advantage. fc of x. What do I need to do? Let me go ahead and print. Actually, let me return this one. Return a value plus image. And I just want to subtract the mean. Actually, let me do advantage here. All right. Perfect. All right. So what I want to do is to assign my hyperparameters. So to do that, we are kind of defining our formula. So basically, I am going to assign the number of episodes that I want, and I've already established them to be 500. Then the learning rate, and then gamma 0.99. So the mean here will be 0.01. Let's set the decay. I want it to be on 0.99. 995. What about the memory size? Let's set up a larger memory buffer, 100,000. And we're left with batch size. My batch size, and we want to update the target. The frequency want to set it on 5. All right. So now we have defined the hyperparameters. Let's initialize the environment. We say we're going to use the CADPO environment from Gym. All right, so to do that, we're going to set our environment is equals to gym.make. We say it's going to be CADPO version 1. Where is it? I'll copy this one. All right. State size. So we want to have our environment. Shape will be 0. Let's do action size. All right, our environment dot action space dot n. Now I want to go ahead and initialize the model. So to initialize the model, I need state size and action size. Then okay. So to do that, I want to say policy DQN, which we set up here. So that's where we need our state size and action size. Perfecto. Then our target net. DQN state size action size. Then we're gonna go ahead. I'm gonna be a little bit faster now. Load state. So we want policy net dot state. Perfecto. Then target net evaluated. Then also optimizer is equals to optim. We're gonna use Adam policy dot dot net dot parameters. Our learning rate, we already set it. So I want to, let me double check what I set my learning rate to be. All right. Okay. I'm using Adam. Okay. Memory. My max lane. Let me double check what about 100,000. Okay. Perfecto. All right. Let's come up with a function to select an action Uh, so I'm going to use double DQN. All right, to do this now, I want to come out the function. I'll just go and select action. So I'm going to do state if random is greater than, actually I want it less than. What do I want to do? And I'll return a random choice. So okay. Else on the printout that I'll do, I'll save this code. I will also add some notes so that I can explain deeper when you do your follow along. I'll return on policy.net, and here I want state. Yeah, item. Now, let me use the loss function. Most likely, if you are doing you might use your MSC loss, but let me go ahead and use Haberlos, because Haberlos is kind of more, to me, it's more stable than MSC loss. So I'll just do Haberlos input target delta is equals to perfecto minus just target here. There it goes. Yeah. Then mask is equals to my error absolute value. Let me match it with a float here. All right. Oh yes, I'll wrap everything in the float. Okay. What I want to do is 0.5 times the error plus yes, plus times delta 0.5. Let me come up with a training function here. Let's train our model. So to do that, all right. So train if just wanted to return here. Let's do batch is equals to random dot symbol page size. Then stats. I want to zip and perfect. I'm going a little bit faster here. Touch. Yeah, well, let's use long tensor, and we have our actions. Set it to 1. All the words. We just use the words here. Yeah. All right, let's set next stats. A float tensor. Next stats. And next. Perfecto. Now I want to go ahead compute my Q values. So to compute values, I need a variable here. Current will be policy. Stats. Dot get. Yes. Perfect. Next Q values. All right. So it will be contemplating to find the best next action, either to turn go up, right or left. So we're gonna set it up. So we're gonna do next Q values, the one dimension. Next Q is equals to my target net. Then we're gonna do next stats. Uh-huh. Let's detach it. All right. Mm-hmm. Let me set it to 1. Then, all right. Let's go ahead and, okay, expected Q. It's just rewards. What would be our, let's set up the loss function. All right, let's set up the loss function. Just loss is equals to expected Q. Perfecto. Let's go ahead and do let me do out of this training loop. And now I'm out of this function. Set the training loop. All right, so to set the training loop, I think that's the last thing that I want to do. Yes, let's go ahead. All rewards, then we're gonna arrange the range of all our episodes. So my environment, I'm gonna reset it. Then state, state. So total reward initially to be, remember we want to track this one. So initially I'll set it on 0. So for step in range 500, which is the maximum episode that we have. Yeah, action is equal to select action, then excuse me. All right, next step. Reward and done. This will be action. Let me go do sometimes we need to shape our reward. to encourage balance. So I want to do that here by reward plus 1. This will be next. It will be next state. State, action, reward, next state, and done. Then state is equals to, this will be just next update. Actually, next state. Then total reward, total reward. All right, so if we're almost done, I'm almost done here. Let's break it. Then what I want to do, just train. Let me see. All right. And yeah. Let's update my epsilon. We want to use the max. And times the decay. Node is equals to 0. Then target.net, we lost it. Dot state dict. Yep. Rewards dot append on appends total reward. Let me subtract average reward is equals to with all rewards. All right, this is done here. We want to print our episodes. We want to see how many they are. Then rewards is equals to, we want to just do total rewards in here. Let me just format it. Then let's do average rewards. On last 100 is equals to AVG reward, and also what else should I track here? Let's go ahead and break it if we attain the result that you want. So reward, if the reward is greater than, we said 475, print environment solved. We can also maybe enhance it by printing the number of episodes, but let me go ahead and break it, then run everything. Environment, close, and run it. Oh, all right. So let me just do a quick one to see if there's any, there are errors. Of course, there will be, and solve them and run and see what we got. So I'm gonna run first and then okay, and solve these errors. Then run the code one more time and see if we could. Why is it jumping to the end? All right, let me pause the video. All right, so it's running. Episode 47, 80. It's finishing. We're on 205, 219, 300, 37, 400. Yes, it finished. But you can see from my results, I'm tracking. The agent was doing well. The total reward was 70. We were catching, we won 475. And it was doing well up to episode 9 with 107, with 177 here. And episode 3 went to 227. And now it dropped to 62, 250, 369. Let's see, 463. This is interesting. By episode 31, our results were 463. Our target is 475. Let's see. It's going down 106, 264, 130. Episode 94, 67. 194, 203, 147. So it's still short of the target 475. So we're gonna see 90. We are looking at the total reward here. 50. It's now going down. It's now going down. 55. Ended up on average 55 and total 67. So it failed to reach our target score of 475, average score of 475. So to do this, what I need to do is to refine this code. I've got ideas that I have, and after refining this code, I'll see how best I can change. Maybe I need to change my learning rate, the batch size also. And also I just need to maybe tune my epsilon decay, mean epsilon, to ensure a better balance between exploration and exploitation. And also shape my rewards. Yeah, I'm gonna play with it and see if I can improve my results. So for now, this is how you do it. And basically we are training. I have a video somewhere here. I'll pin it on the as we start this tutorial. But thank you for watching, and bye for now.